Hello, everyone, and welcome to this webinar, AutoBalloon and Extract GD&T in 2 minutes. Learn how you can speed up ballooning, FAIs, PPAPs, and more. Brought to you by HiQA. I am Lisa Sterling, your host and moderator for today's session. Before we get started, though, I would like to mention just a couple of housekeeping items. We invite you to ask questions throughout the presentation by typing into your Q&A tab found at the bottom of your screen, as your phone is muted during the session. We will address the questions received at the end of the presentation. Please note that this webinar is being recorded and will be available in a few days for playback. I would now like to introduce you to our presenter for today, Ryan Ganser, Regional Sales Director at HiQA. And with that, I will turn the floor over to Ryan to get us started.
Thanks, Lisa. So before we do jump into the software, everybody, I just want to thank you for taking some time out of your day. We'll be pretty high level in terms of showing some functionality. And specifically, we're going to focus a lot of time on the one-click ballooning, right? Being able to automatically extract the GD&T or PMI data, leveraging our OCR technology. Throughout the demonstration, you're never going to see me cut and paste. With that, we're eliminating the manual errors, and ultimately, we're saving you time. HiQA is a centralized database, so also throughout this demonstration, you're never going to see me save as or put something in a different folder or anything like that. It's all done inside of a centralized database, all in one spot. Specifically, we're going to be focusing on generating these first articles and PPAP reports, all again inside of one spot, fully traceable and automated. A little bit about HiQA. We have just over 1,300 customers on 5 different continents, consisting of over 200,000 or 20,000 users worldwide. Bulk of our customers and users are in the aerospace, defense, medical, and even some automotive industries. So with that, data security is at the forefront. We are fully ITAR compliant. Again, our customers being in the aerospace, defense industries, the data security is certainly a priority for us. Lastly, everything that you see here has been driven by our customer driven culture, right? Focusing on what is most important to you guys. That's driven our innovation throughout the years. Our vision, mission, and values, right? Our vision is to simplify and automate manufacturing quality. By doing so, we're aiming to be on time, on budget, and on quality. And lastly, our values, innovation, integrity, and teamwork, all working together with one another. So this wheel that you see over here on the left-hand side of the screen, it's a good image to kind of visualize everything that can be done inside of HiQA. As I said, we are a database-driven solution. So everything that you see here is done inside of the database to ultimately save time and promote consistency. We separate this out into 4 different areas. So kind of the outer circles that you see here. First, we have our part and job planning. We'll focus a lot of time today within this section. And then we move on to our production and data collection, ultimately our reporting and submissions. Everything that you see in the green here is kind of from an internal perspective. We also have a supplier collaboration tool as well that goes externally out to your suppliers, ultimately bringing your suppliers to your shop floor. So that's kind of the mindset here within HiQA, again, all inside of one centralized database. Okay, now let's jump into the software. We will be pretty high level here in showing some of the core functionality. As a potential next step, we would love to dive deeper into the software with actually some of your own prints. So keep that in the back of your mind as we jump into things. Okay. So what you're seeing here is our HiQA system. It is an on-premise solution. So again, aerospace, defense industries, we're not leaving your network walls. I'm just going to bring in a drawing that I have saved on my desktop. All right. Simple machined part here, right? Not too much going on. Just know that we can take on much more complicated drawings in this. Just from an intro demo perspective, we don't want to be overwhelming. But again, as a next step, we're happy to take a look at your guys' drawings. General functionality, I can move the drawing around with my mouse. I can zoom in, zoom out. For us, everything starts at the auto ballooning phase. And I'm sure that's why the bulk of you are here. As we said, being able to auto balloon and fully create an FAI in just a couple of minutes. So the first thing I'm going to do is up here at the top. I'm going to click auto balloon GD&T. And we do have different preferences. So if you had multiple pages, you could balloon them all at once, or maybe you only care about ballooning pages 2, 3, and 4. You can choose select pages or just the current page that we have selected here. You can also tell the system that you don't care about basic, reference, general tolerance dimensions, things like that. At this point, I'm just going to click OK. And we're sending this print through our OCR. For those not familiar, OCR stands for optical character recognition. This is a proprietary technology that literally took us 6 years to develop. It is certainly our biggest claim to fame. I can confidently say second to none in terms of not only speed, but also accuracy, right? That GD&T recognition. And you can see here, 17 seconds, we created 24 balloons consisting of 34 dimensions. And as you see here, we're fully ballooned. Even more important or impressive, I would say, is what you see down below here. We call this our bill of characteristics. This is everything that we extracted in that first 17 seconds, right? This is all now saved to the database. Essentially, this is your inspection plan. Just to highlight a couple of fields, we have the dimension or the balloon number, dimension type, requirements. If there are any multipliers, if I scroll down here, I think we got some, we'll automatically recognize those as well. Nominals, tolerancing, all saved to the database, right? You can export this out as an Excel inspection plan if you want, just off the bat. We'll show some additional functionality here as well. So now I want to transition to the concept of part categories. So I'm clicking in our part properties tab here, and you can see up here at the very top, I'm under Ganser machine as my part category. And this part categories, you're going to see this kind of show up throughout today's demonstration, but it's worth emphasizing. The easiest or quickest way to describe what a part category is think of it as like a series of defaults or preferences that all roll up into this part category. So our customers, they'll use these part categories for their customers or part types, part families, things like that. But again, it's just a series of defaults that roll up into that part category with the mindset of, hey, let's get things set up ahead of time based on these preferences and defaults in such a way that we can just automate downstream. You'll hear me say that term a couple of times today. Being able to automate downstream is significant, not only for speed, but also consistency, right? So a couple of factors that roll up into our part category. One is our sampling rule that you see here down below on our inspection plan. My part category is set up to sample at 1 per lot. Now, at any point in time, you can always change these just by clicking in, right? I can change from 1 per lot. You can see I'm at X per lot with a value of 1. I can sample based on an AQL table, percent from lot, per hour, per shift, per X, whatever I want. But again, this is just set up as my default. Additionally, we have this gauge category. So if I click on a dimension over here to the right-hand side of the window, just think of this as like a peek into the database, right? This is what the system came up with. But focusing on this gauge category. Again, part of my part category, my system says that if it's a linear, we're going to use a caliper. Now that's a category. It's not an individual caliper. And that's going to tie into our gauge management tool, which we'll show here in a bit. And that'll ultimately streamline out to the shop floor for data collection, right? Hey, this is a linear. You're going to use a caliper. Here are your non-expired available calipers. At that point, you can digitally check in, check out, type in your results as you're making your measurements, and then you have that traceability because again, you're doing everything in one spot. So for that caliper, that specific caliber, I know who used it, when they used it, and what the results were. If that doesn't make sense right now, it promise it will in about 20 minutes. So, but again, this gauge category, that's still under these part categories, right? Additionally, so when we're talking about our OCR, if the tolerance is on the print, so like this plus plus here, you can see over here to the right, we will bring that in. If it's not, so going back to this 2-inch linear, this plus or minus 10 thou, that's coming from, we have tolerance tables built in the background, which also roll up into those part categories, right? Customer specific, part type, part family, whatever you want. Just to show that when we're talking about tolerance tables. So we're still under my part properties tab. I'm going down below, I'm clicking this tolerances. And right, we have decimal tables, range tables, just to show you a decimal table real quick. It's kind of what you'd expect, right? Based on decimal points, here's the default tolerancing that we'll bring in. English, metric, angles, fractions, all part of the database. Again, promoting that automation and consistency. Okay, so now let's look at this title block down below. So the way our OCR works is it starts in the top left, it's moving left to right, top to bottom, kind of like a typewriter, identifying all the dimensions, looking for the GD&T and extracting that into the database. Anything that's connected to our outer border, so like our title block, for example, we're not looking inside of strategically. But we have a couple of different tools to still do things much more quickly and consistent than a manual process. So up here in the top left, I'm hovering over these various icons. I just call these efficiency tools. We'll touch on a couple of them today. The first one being this extract title block text. So by me clicking that, I can now grab information from our title block. So I'm box selecting. So clicking, dragging, and once I drop, I can tell the system, hey, this is our part name. And if you notice here on the right-hand side, again, right-hand window, think of it as a peek into the database. That part name is now populated with that shaft clamp bracket. Do the same thing with part number. Not having to touch the keyboard, everything's saving to the database. Any reports or forms that you populate are going to be automatically filled out with this, in this case, the part name, part number. Do the same thing with Rev. I like to point out this Rev because it is a different size and style text. So again, our OCR being our biggest claim to fame, being able to recognize that different size and style, it's a differentiator for sure. Now, at the end of the day, these are open text fields on the right-hand side. So if I wanted to just type in that B, I could have. I just like to showcase that technology. Okay, so we talked about the tolerancing. Next, we have notes. So for those of you that are required to balloon notes, we're intentionally not going to auto balloon notes. There's really just no standard for us to do so. But another tool we have, highlighting over it now, this T icon to balloon notes. Click that. That flips our OCR so that we're no longer looking for GD&T. We're just looking for text. And just as I did with the part name and part number, just going to box select. Clicking, dragging, and dropping. You can see we'll assign a balloon number next to them. And then down below, as part of our inspection plan, we have those 3 balloons, 25, 26, 27. as a note. Again, right-hand side, these are open text fields, so you can type in your own note if you wanted. And then on the drawing itself, we do have these automatic leader lines. So just kind of cleaning things up as things get a little condensed. Everything that you are seeing here is customizable in terms of, sizes, shapes, colors, things like that. Um, and then when we go to acquire the results, the data, a lot of our customers will just treat these notes as like a pass fail. Okay. Next, moving on, we have our material here. So just below the T to balloon notes, we have this M to balloon material. And again, we're box selecting, clicking, dragging, dropping. Over here to the top right of the page, we automatically flipped to our materials and processes tab. You can see the T6 that I captured. At any point, if you see a pencil inside of HiQA, that gives you the opportunity to drill down and add more information. So if I click in there, right, I can add a material code, a spec number, cert number, indicate who the supplier is. I can also upload attachment files. Most commonly here is like a material cert. Again, everything saves to the database. Any reports that require material cert, it's going to automatically populate. Okay. Next, let's touch on this balloon 17 here. This one's interesting for a couple of reasons. One, we have the 4x for our 4 holes that you see. And as you see down below, we're automatically bringing in that 4x multiplier. But also it's a stacked dimension, a diameter, thread, true position. So really there's 12 lines of data, right? The 12 or the 4 times 3 in this case. So depending on how you want to view things or how your customer would like to see things, we have a lot of flexibility here. If you wanted this to be 3 separate balloons for each dimension type, 17, 18, 19, for example, when I originally auto ballooned, one of the preferences is just like the split sub characteristics. So it would have done exactly that. If you want to explode the multipliers out, we have this multiply dimensions button over here to the far right. By me clicking that, a couple of things happened. Down below, all 12 callouts are now shown. 17.1 underscore 1 all the way down to 17.3 underscore 4. On the drawing itself, this is just how my system's set up. I have these little sub balloons created. Drag them over the individual holes if I wanted. It's all in the database either way. We're just changing how we're viewing things. Take that back off. Okay. Now, when we talk about our OCR again, it's definitely our biggest claim to fame. I'm reiterating myself, but it's worth emphasizing. I don't want to give the expectation that it's going to be 100% accurate every time, right? If it's a scanned print from the 70s that's maybe hand drawn, chances of full automation is just unrealistic. But blanket statement, there's no level quality drawing that you're not going to be able to fully complete, fully balloon, inspect against, and report against inside of HiQA. You're never going to have to leave this system. So let's just pretend that we did miss a dimension. So this one in the middle, maybe. I'm going to delete it. We missed it for whatever reason. Another efficiency tool we have up in the top left is this whiteout balloons. By me clicking that, we're going to hide everything that's already been captured, right? So now it becomes very obvious, hey, this 2-inch was missed. And we can just box select to capture it, to reballoon it. Over here to the right, double check what the system comes up with. It's a 2-inch, it's a linear. Based on the decimal points, we're going to plus or minus 10 thou. Based on it being a linear, we're going to use a caliper. We also have the ability to designate different levels of criticality. So for those of you that are required to designate like a a key, major, minor, or CTQ, critical to quality, you can do so right here. Completely customizable in terms of what you label them and what happens when you do label them. Let's take off white out here. So by me designating this as a CTQ, a couple of things happened. You can see we have the designator called out on our inspection plan. My system also automatically flips to sample based on an AQL table that I have set up. And then on the drawing itself, we go from a circle to a hexagon, right? Just visually, hey, this is different. This is critical. And then I'm imagining most of you are noticing that we're out of sequence. We're going to 11, 28, 13. Just because I deleted it and then added it, we kind of go to the end there with balloon 28. If you want to get things back in sequence, you just click numbering up here at the top. Just like that, we're back in order. So that's kind of the basic core functionality of our auto ballooning, right? Getting all this, everything identified, extracted into the database. Now to lay out maybe the next 20, 30 minutes, I'm going to touch on gauge management very quickly. We will break down this part into different operations for some like in-process checks. And then we'll move into the data collection side of things. We'll go out to the shop floor, focusing in on our digital shop floor interface. And then I'll simulate data coming from like a CMM automatically. And then we'll be ready to report first articles, PPAPs, all that good stuff. Okay, so up here at the top, we're going to click on measurement gauges. And for those of you that are using an additional software for gauge management or even Excel, you can import your current gauge list into what you see here. By no means do we expect you to type all this information in. So you can see we have this import gauges drop down. But yeah, it's kind of what you'd expect. It's a list of your different gauges. We do have different colors, symboling different things. So if you see it in red with this stop sign here, that means that this gauge actually has expired. In this kind of maroon color with an exclamation, that means the gauge is approaching expiration. We do have notification settings. So you can get emailed or groups can get emailed if a gauge is expired or approaching expiration. And then down below, just general gauge information, right? Here's my caliper, belongs to the category caliper. Gauge ID is caliper 002, where it's located, and different calibration details, when it's due, things like that. Big benefit of using our gauge management system, which is part of the core product, it's not an add-on or anything like that, is from a traceability standpoint. Because if you're doing everything in one spot, communicating out to the shop floor inside of HighQA, having the shop floor enter results inside of HighQA, we have usage history. So if I click our usage history tab for this specific caliper, a caliper 2, I know every part, job, lot, dimension that's been measured. I know what the results were. I know who measured it. I know when they measured it. I can see if there's any NCRs associated with it, right? From a traceability standpoint, it's all right here, one click away. Common use cases are, hey, we got a dropped gauge. When was the last good check, right? It's right here. You can also set up your calibration interval based on usage. So if it's a gauge you're using, every 6 months, calibrating it quarterly might not be the most efficient way of doing things like that. Okay. So next, as I said, we're going to get into our operations for those in-process checks. So I'm clicking this manufacturing operations tab. And we switched colors. This is just my system. This kind of blue-green color signals that we're at the finished part level. You can see up here on the right-hand side, finished part. if I want to assign dimensions to an operation, I can just hold Control, click the dimensions that I'm interested in, and then over here to the right, click Add Operation. And now we're going to have an op10 in yellow, right? Still tied to the original, linked to the finished part, is just sub op10. I can grab dimensions in bulk just by box selecting. So if I wanted to get these holes down there in the bottom left, again, click Add Operation. And we'll do one more just to make it look pretty. Okay, so now we have op10, op20, op30, all linked to the same dimension, just sub operations, right? For those in-process checks in different colors. We have these pencils again, so we can drill down, add more information. I can rename it. Let's just call this our roughing op. I can tie it to a work cell, a machine, or a process. These would be your processes that potentially could be coming from your ERP. We haven't talked about it, but we do have ERP integrations, off-the-shelf integrations. But where that process is coming, tied to that operation. So for those of you that are required to create submission packages, PPAPs, APQP, what we're doing when we're assigning a process is we're building that process flow, your control plan, FMEAs, right? We're building that as we're planning the part. So these were some holes. Let's just say we're going to drill, tie it to our drilling process. One more, we'll call this our turning. Tie it to our turning process. Okay. We can also filter by our operations. So if I wanted to look at roughing, I now have a print just for my roughing op, right? It's just these 5 dimensions that are part of roughing. I can send this out as a PDF. I can export this out as an Excel. Maybe before doing that, I want to update some things, right, for my roughing pass. Select all and bulk update. Now I'm changing my requirements, but only for, in this case, our roughing operation. So if we're looking at the nominal, I can add, subtract, multiply, increase or decrease by a percentage, whatever I want. Let's just say we're going to add 20 thou. And we can change the tolerance to plus 50, I don't know, minus 40. But again, just for our roughing operation. I can also tell the system, hey, I want to change how I'm going to sample at the roughing op. I can say, hey, we want to monitor these dimensions for SPC. This is real-time SPC. As the results are coming in, you're going to see those run charts, various SPC charts get updated in real time. Okay. And now down below, you can see, right? We added 20 thou plus 50 minus 40 as part of the roughing op. So now I'm going out to the shop floor. We're going to look at the shop floor data collection interface. This is browser based, so still not leaving your network, but much more lightweight than what you've seen thus far in the main system. Can be run on like iPads, tablets, or just lightweight computers out on the shop floor, where you can log in. You can also scan in if you wanted to. And it would look a little something like this. Very similar to what we've seen thus far, right? Here's our print. You can move it around just as we did. You can zoom in, zoom out. We do have a little tolerance bar down below. So the math is done for them. And again, this is what the operators will see out on the shop floor as they're making their measurements. Let's say I was assigned the roughing operation, right? It's just those 5 dimensions that we assign to the roughing op. Those are the only ones I'm going to be asked to measure in this case. Requirements were changed, right? We added 20 thou plus 50 minus 40. Because it's a linear, we're going to use a caliper. So now when I go to select my tool and gauge, click in this box, This is where that gauge management comes into play. I'm only showing calipers that haven't expired. If you remember, I had a few that were expired. You can see them here. This is where you can digitally check in, got my caliper 2, enter in my results. A good check will turn green and auto toggle to the next dimension to be measured. If you're wondering why this measured result box is blinking, we do support Bluetooth wireless gauges where those results can literally come in automatically. Let's just type in another one just to show you. Good check, turns green, auto toggles to the next. Now, this is one of the few times I'm touching my keyboard, actually typing in information. So there's the potential for human error. Let's just pretend I accidentally typed in 40 instead of 4.0. Get this little error message. Hey, this is out of tolerance. Do you want to measure it again? This is where, oops, fat fingered it. Yeah, I do need to measure it again, or no, maybe this is a failed check. I would click keep failed. We now have the option to populate an NCR, a non-conformance record, at the point of failure, right? And since I'm doing everything in one spot, I already know the job, the person, the date, the lot. We just auto serialize an NCR number that you could change if you wanted. These would be your defect types and defect codes with the legend indicating what each code means. Again, promoting that consistency, not just saving time, but error reducing. So it was a tool break. Now we have an NCR tied to this dimension at this operation for this part and job. It'll also turn red for a failed check. For like a visual check or those notes that we talked about for like a pass fail, it would look something like this. Pass it, turns green. Okay. So that's the shop floor interface. Again, this is for your manual checks, your calipers, your mics, stuff like that. Designed to be very intuitive, not overcomplicated by any means in terms of, hey, these are the dimensions you're asked to measure. Type in the results with a couple of safeguards in place. Math is done for them, and that's going to flow back into the main system, to the database. Okay, so now going back, we have a module, it's called automatic machine data import, where essentially we're connecting to CMMs, VMMs, Pharaohs, it doesn't matter. If it's an automated measurement device that runs on software, we connect to those automatically, where as a background running operation, every time those machines make a measurement, we're bringing those results in real time. So talk about eliminating data entry, time savings, and errors. Uh, Having that module in place is certainly a huge time saver. So I'm not connected to a CMM, so I'm just going to simulate that process. And to do so, I'm going to import a static CSV file. So up here at the top, I'm clicking import. I'll even just open it up real quick just to show you guys. Simple CSV file, which any CMM has the ability to output. Our team will handle the translation and everything, just setting up the integration between the two systems. The main reason for me importing this file, for the sake of time, we have all these actuals. Okay. So this is the file I'm now going to import. But again, this would be coming in real time in the background. Similarly to what you saw out on the shop floor, red is a failed check, green is a good check. Gray actually means it's not yet measured. So another way you can enter results is here through this main interface. So if you look over here to the right, this is talking about that gray that's not yet measured. It's a thread, simulating a CMM, not going to measure a thread. As I said, you can enter the results here. turns green. Down below, we have all of our results. So just to kind of recap how we got here, we auto-ballooned this print, took 17 seconds. We captured information from the title block, part name, part number. We manually ballooned some notes. We pretended that we missed something. We whited out everything to see what it was that was missed. Manually ballooned it, designated it as critical. And then we went out to the shop. Well, we broke this down into operations in process. Then we went out to the shop floor for data collection, simulated data coming in from a CMM to get where we are now. So we have the requirements, we have the results. Now we're ready to report. So if you wanted to do a simple first article, you would click inspection reports drop down up here at the top. This is just a single piece. And then all of your reports are going to be templatized in the system. So whether it's an AS9102 or you need net inspect or whatever the case may be, we're going to templatize them inside of the database where you click a couple buttons and they're automatically filled out. Click create report. We're going to do an AS9102, Reb C, exporting out to Excel. And it's on my other screen. Here we are. So this is AS9102. Again, Form 1, Form 2, and Form 3. There's different tabs down below. This is Form 1. This obviously would be your logo. We have our part name and part number that we captured at the beginning. We have our material information that we also captured at the beginning. And we have all of our results. A lot of people like that we have the symbols automatically populated here. Been told that's a pain. And you have your results with little color codes. If you remember, we designated dimension 12 as a CTQ. There it is. Attachments, right? We have our material cert as well as an image file, PDF. All here, all saved to the database, ready to send out to your customer. Additionally, as I said, everything saves. If this is a repeat part for whatever reason, you're never going to have to do any of those initial planning steps again, right? It's saved to the database. You just run up a new job up against it. All reports saved in real time here. You click this little eyeball, it'll take you directly to the report that was generated. Okay, so that's first article. I do want to leave some time for some question and answers. So let's just breeze real quickly through the concept of generating PPAPs, which as we were tying our manufacturing operations and tying those to a process, that's going to link out to a process library that's set up in the database where your PPAPs, your submission packages, will be quite literally automatically generated. So I'm going to bring in a demo print here just because it's more kind of more fleshed out for the sake of time. But it's the same concept, different part, but same concept. If you look over here, we have our operations. Op 10, size cut, drilling, turning, milling, finish, tied to our processes. So when I go to my PQP records tab here, this is my specific submission package. So we call these indexes, which think of it as a library of documents. This specific index consists of a process flow, an FMEA, control plan, AS9102, and gauge R&R, part submission warrant. These documents are automatically populated. They're also linked to one another. So let's just click in here to our process flow. This is my process, my individual process flow for this part and job based on the processes that I've identified. Each one of these documents has a digital workflow, completely customizable, by the way, in terms of who's involved and what happens at each stage as things get submitted, signed, or even declined. You get email notifications. You also get notifications here inside of HiQA. So that's our process flow. And as I mentioned, these are linked to one another. So let's say your process flow changes. Your control plan is automatically going to reflect that change. They're linked to one another. So from an auditor's perspective, I'm been told that's usually one of the first places they look. Hey, you changed your process flow. Why didn't your control plan change? Using a system like this, that's impossible. They're linked. Here's your control plan. Again, digital workflows. Here's your FMEA. All this information as part of those process libraries that are in the background, populating things automatically. Once everything's done, this progress bar is at 25% just because I have a 4-step workflow. So we're in step 1 of that 4-step workflow. Things move to 100%, get signed off, can build a final package here where essentially we're consolidating all of these forms, these documents into one large single PDF ready to send out to your customer. Okay, so that's kind of the high level overview of the HiQA system. Jump back here to this PowerPoint. Couple other things that we do want to emphasize. I mentioned it. We do have an open RESTful API where we can connect and integrate with various outside systems. We also have several off-the-shelf ERP connectors with some of the more common ERPs in the industries, where essentially the integration's already been established. It's maintained by us. It's really a plug and play integration where we're pushing and pooling different areas of information. Also, when we talk about support, hopefully you got an understanding of the system is highly configurable in terms of how you and your customers think about the quality management processes. Getting that set up and configured the correct way is vital for your success. So by no means is it like a sign up and you're off on your own. We have a highly sophisticated and involved onboarding process, which we're happy to go into more details, but just kind of know that we have we do this a lot with a lot of large organizations. So the onboarding process is certainly um, sophisticated and involved and hands-on by our team. Okay, so in short, IQA, hopefully you got an idea of how it can be a one-stop shop, right? A centralized source for all of your quality manufacturing management needs. Whether that's 2D or 3D models even, um, being able to automate to your inspection plans, drive that data collection, um, report on it from a first article or even PPAP perspective, really SPC if you need it. Tools and plans are customizable to your needs. Okay. So I think, or at least hopefully some questions were submitted to Lisa. Lisa, I'll let you kind of read them off, and if I can answer them or even demonstrate the answers, I will.
Sounds great. Thanks so much, Ryan. Yes, several questions have come in, and again, you can still type in. There's still time. It's right at the bottom of your screen in the Q&A tab. Okay, let's get started. The first one says, is it possible to AutoBalloon without the PDF having the OCR profile?
Is it possible to auto-balloon the PDF without having the OCR profile? I'm not entirely sure on what that question means or is asking. When we auto ballooned, we identified the border, the outside border, and then we're scanning for GD&T. Now, if you wanted to manually do things, you click this scissors icon. Let's just say there was a dimension right here. And you could label this whatever it ever you wanted. Say it's a true position, type in your information. Um, Not entirely sure if that's what the question was being asked. Um, if if further clarification is needed, please just type in um, any additional follow-up questions you might have.
Yes, and if there are any questions that come in that we happen to not get to due to the sake of time or whatnot, we'll be sure to follow up with you directly following the session.
Perfect.
Okay, so there are several questions. Here's another one. For the floor view, if we have a metric print, can the tolerances and measures be displayed in imperial?
Yeah, absolutely. So the system is highly configurable, and it's designed to be collaborative. So when we're switching, if you want to switch between metric and imperial, we have this little show alternative units button. It's the conversion was already done in the database. We're just changing views. So whether that's here or out on the shop floor, the the theory applies. It's in the database. How do you want to look at it? Simple as that. Good question though.
Great, thank you. Okay, another one says, how about MBD models? Can you auto balloon semantic 3D annotations PMI?
Yes, we do have a 3D MBD module, and a couple of things that was mentioned in that question are a necessity. It does need to have PMI embedded in there, right? There needs to be some dimensions for us to see. Um, those those native and semantic files, those are things that we can 100% work with. We bring that model in, and essentially we're converting that model into a 2D print, and then from that point, it's everything that you saw here today is handled the same way. But yes, we do support 3D model-based definition.
Yes. Okay, here's sort of a two-part question. It says, how accurate is the auto ballooning? And then how about for scan drawings and accuracy for scan drawings?
Okay. First question, how accurate is the auto ballooning? I confidently second to none in the industry. Like I said earlier, that's why we'd love to show you your own drawings. If it's, as you said, something that's been scanned in several times and there's poor resolution, there's only so much the OCR can do from an automation perspective. But that's why we do have these manual tools to capture things manually. But I said it earlier, once you do it once, it's saved to the database. So if it's something that's been scanned in several times, and it's a repeat part for you guys, you do it one time, you're done. You run multiple jobs up against it. I'm sorry, what was the second part of the question, Lisa?
Okay, let me double check. Oh, how about for scan drawings and accuracy for the scan
Oh,
drawings?
okay. So I believe I answered that
Yeah,
as well. But um, just to emphasize, would love to take a look at your guys' own drawings. It's the best way to get an idea of how much value a system like this will provide specifically for you.
very efficient. Okay, here's another one. Can this connect to Keyence software to auto import or input measures from a machine scan out of a unit like the VL or IM?
Yes. So that's part of our automatic machine data import module, where Keyence is definitely a very common one for us, where our team essentially, so we're installed on your server, right? We're a database on your server. We set up folders on your server for each of your machines. Our team will then map from your Keyence to those folders every time a measurement's made. We then set up HiQA to listen to those folders. Anytime the folder is populated with results, we're automatically bringing in those results and then archiving them. So quite literally, it's fully automated, done in the background. We're bringing those results in real time.
Nice. Okay, here's another one. Can it pull general tolerances from what's shown under tolerance unless noted?
Can you say that again, Lisa? Sorry.
Sure, it's okay. Can it pull general tolerances from what's shown under tolerances unless noted?
Can it pull? Yes. Quite simply, yes. It's
Okay,
pulling in those general tolerances. If it's on the print itself, let's go back to the other one we were looking at. It's got some more tolerance on the print itself. If it's on the print itself, like this plus plus, we'll bring it in. If it's not on the print itself, you can see here we have a general tolerance here. That's where we're pulling from those tolerance tables. Any others, Lisa?
oh yes. Okay, here's a few more. Can HiQA tell CMM which physical components to measure and how to measure them? Or was the CMM programmed separately by the operator based on the list of measures?
Um, let's flag that question. I'm not entirely sure on what's being asked, I guess. Um, if we can just flag that, Lisa, and then we can reach out in the next day or so with a full explanation. Might need a quick phone call as well.
Sounds good. Here's another question. Is it possible to start small and grow into the full functionality of HiQA? And or is it easy to add additional modules?
Yes, 100%. It's actually pretty common. I always use the analogy of walk before you run. Um, Plans are module based in terms of number of licenses and also what those licenses entail, what they have access to. So if you really only wanted to balloon, create inspection plans, and export things out to Excel and import it back in, and then 6 months down the road, you're ready to add some more automation or additional, maybe you need PPAPs or whatever the case may be, you just add that at any time. We are on annual subscriptions, so we would just prorate the cost for however much time is remaining in your contract.
Great. And lastly, due to the sake of time here, we'll wrap it up with this final question. How long does it take to get trained on the software?
Yeah. Um, it kind of depends on what type of plan you have. Um, we have dedicated hours of time based on plans that our team will work with you. Um, how you use that time is totally up to you. Just last thing we want, right? Everybody, we still need to make parts. So by no means do we want to stop production to learn this. So first thing we'll do is meet with your IT team to get this installed. And with that, we establish an agreed upon timeline on how you want this implementation to go. Essentially, long story short, however fast you want to move, we can do. We have some people, hey, I just want to be ballooning. We get you up and running in a day or two, based on your availability. So we also, when we're talking about training, we have an online academy, which is unlimited and self-paced, where we actually walk you through your plan through the use of interactive videos. By interactive, I mean you're actually like clicking the buttons to move through the video just to increase that retention. We have quizzes to get certified on, whether that's a new employee that comes in at any point or just to get up and running. And then we supplement that with like a Teams or Zoom call where we take you through your plan, your processes, through the entire process with your drawings. So kind of a couple different angles from a training perspective that we've determined to be the most effective use to train. but that's all determined by a timeline that makes sense with you.
Makes sense. Thank you. I also in the chat, I dropped a little link there if you're interested in having a one-on-one session that Ryan mentioned earlier in this webinar. We're happy to take time with you, again, one-on-one with your prints, with your data. And there's been a lot of questions, so that gives you the opportunity to ask more specific questions to your needs as well. So we encourage you to do that. Thank you so much for joining us for this webinar and spending the hour with us. Thank you, Ryan, for presenting, and we'll see you all at the next one.
Yep,
Have a great day.
absolutely. Thanks, everybody.
Thank you.
Bye.